We're still discussing about the remainder theorems. But now let's look at the situation when the divisor is a quadratic expression. When a polynomial px is divided by a quadratic expression ax squared plus bx plus c, then the remainder is rx equal to ax plus b. Therefore, you can have px equal to qx times dx plus rx. For rx here, it must be ax plus b, since dx, which is the divisor, is a quadratic expression. Example 6. By using remainder theorems, determine the remainder when px equal to x cubed plus 3x squared minus 3x plus 4 is divided by x squared minus 4. You must note that the divisor here is a quadratic expression. That means the remainder will be in the form of linear expression, which is rx equal to ax plus b. You need to find the value of a and b. So, to find the value of a and b, you need to have at least two equations. So, how to form that equations? First, we need to factorize the divisor here. So, we have dx equal to x squared minus 4. I'm going to factorize this divisor, which is we are going to get x minus 2 times x plus 2. So for x minus 2, we're going to have x equal to 2, and for x plus 2, we're going to have x equal to negative 2. So first, for x equal to 2, we'll apply the remainder theorems. We know that P2 equal to R2. So I'm going to substitute x equal to 2 in this polynomial and also the remainder here. So we have 2 cubed plus 3 times 2 square minus 3 times 2 plus 4 equal to, for the remainder here we have a times 2 plus b. So we expand these equations. We're going to get 8 plus 12 minus 6 plus 4 equal to 2a plus b. Rearrange these equations. I will write 2a plus b on the left hand side equal to 18. This will be the first equations. Now for the second equations, we're going to have x equal to negative 2. So when x equal to negative 2, we know that p negative 2 equal to r negative 2 by the remainder theorems. So the same things, which is we need to substitute x equal to negative 2 in this polynomial, also in this remainder. So we have the bracket negative 2 cubed plus 3 times negative 2 square minus 3 times negative 2 plus 4 equal to a times negative 2 plus b. I will expand these equations. So we get negative 8 plus 12 plus 6 plus 4 equal to negative 2a plus b. We are going to simplify these equations. First, I will write negative 2a plus b on the left hand side equal to 14. This is going to be the second equations. Next, we are going to try to find a by taking equations 1 minus equations 2. So we have 2a minus negative 2a, which is you're going to get 4a, and then b minus b equal to 0. Next, 18 minus 14 equal to 4, so a equal to 1. So next we are going to substitute a equal to 1 in equations 1 or equations 2. So I will try to substitute into equations 1 to find the value of b. So we have 2 times 1 plus b equal to 18. And then we have b equal to 18 minus 2, which is 16. So now we can substitute the value of a equal to 1 and b equal to 16 in the remainder, which is Rx equal to Ax, which is 1 times x is x plus b is 16. So therefore Rx equal to x plus 16. Example 7. The polynomial px leaves a remainder of 1 on divisions by x minus 3 and a remainder of 3 on divisions by x plus 3. Find the remainder when px is divided by x squared minus 9. You must note that the divisor is quadratic expressions, so the remainder will be a linear expression, which is Rx equal to Ax plus b. You need to find the value of a and b, and in order to find the value of a and b, we need to form at least two equations. First, I'm going to factorize this divisor. So we have dx equal to x squared minus 9 equal to x minus 3 times x plus 3. For x minus 3, we are going to refer to this information, which is px leaves a remainder of 1 on divisions by x minus 3. For divisor x minus 3, we have x equal to 3. By applying the remainder theorems, we know that P3 equal to R3, which is 1, since remainder is 1. And for x plus 3, we're going to refer to this information, which is remainder of 3 on divisions by x plus 3. Since the divisor is x plus 3, we're going to have x equal to negative 3. And by using the remainder theorems, we know that p negative 3 equal to 3 since the remainder is 3. Okay, now for p3 equal to 1, we know that p3 equal to r3. So I'm going to use r3 equal to 1. And for R3, I'm going to substitute here, which is x equal to 3. So we have a times 3 plus b equal to 1. So we have 3a plus b equal to 1 as the first equations. Next, for p negative 3 equal to 3, I'm going to write r negative 3 equal to 3. So we're going to substitute x equal to negative 3 in this Rx. So we have a times negative 3 plus b equal to 3. So negative 3a plus b equal to 3 will be the second equations. Next, let's try to find the value of a by taking equations 2 minus equations 1. So we have negative 3a minus 3a, which is negative 6a. Next, b minus b equal to 0. And 3 minus 1 equal to 2. So we have negative 6a equal to 2. So a equal to negative 1 over 3. To find the value of p, you can substitute a equal to negative 1 over 3 in equations 1 or equations 2. I will choose to substitute into equations 1. So we have 3 times a, which is negative 1 over 3 plus b equal to 1. We can simplify this part. So we get negative 1 plus b equal to 1. So b equal to 2. Therefore, you can substitute the value of a, which is a equal to negative 1 over 3, and b, which is b equal to 2, in these equations. So we have Rx equal to negative 1 over 3x plus b. Example 8. The polynomial px equal to x cubed plus bx squared plus qx plus 8 gives a remainder of 2 minus x when divided by x squared plus x minus 2. Find the values of p and q. In order to find the value of p and q, you need to form at least two equations. First, I will take out the information given. We have the polynomial, which is px equal to x cubed plus bx squared plus qx plus 8. Next, we have the remainder, which is equal to 2 minus x, and the divisor is dx equal to x squared plus x minus 2. Next, I'm going to factorize the divisor here since this is a quadratic expression. So we have x plus 2 times x minus 1. Next, we're going to have x plus 2 will be x equal to 2, and I'm going to apply the remainder theorems. That means we're going to have p negative 2 equal to r negative 2. So next, we're going to substitute x equal to negative 2 in px and rx. So we have negative 2 cubed plus p times negative 2 square plus q times negative 2 plus 8 equal to 2 minus negative 2. So we are going to expand these equations. We will get negative 8 plus 4p minus 2q plus 8 equal to 4. Simplify and rearrange these equations. We will have 4p minus 2q equal to 4. I will divide these equations by 2. So we have 2p minus q equal to 2 will be the first equations. For the next equations, we're going to have x minus 1 here as x equal to 1. So when x equal to 1, by applying the remainder theorems, we have p1 equal to r1. So now I'm going to substitute x equal to 1 in px and rx. So we have 1 cubed plus p times 1 square plus q times 1 plus 8 equal to 2 minus 1. So I'm going to expand these equations. We have 1 plus p plus q plus 8 equal to 1. Next, we have p plus q equal to negative 8 will be the second equations. Next, to find the value of p, I'm going to take equations 1 plus equations 2. So we have 2p plus p equal to 3p, negative q plus q equal to 0, 2 plus negative 8 equal to negative 6. So p equal to negative 2. Next, we're going to substitute p equal to negative 2 into equations 1. So we have 2 times negative 2 minus q equal to 2. Then we have negative 4 minus q equal to 2. Q equal to negative 6. So we can write the conclusions. Therefore, p equal to negative 2 and q equal to negative 6.